Hello, everyone. Today we're excited to share some insights from a significant breakthrough in speech recognition technology developed by OpenAI. The paper is called Robust Speech Recognition via Large-Scale Weak Supervision, and the product is named Whisper. This model leverages large-scale weakly supervised data to achieve impressive and robust speech recognition capabilities.
Yeah, so traditional speech recognition systems require extensive supervised data sets, which are not only costly, but also pretty limited in scope. And then furthermore, these traditional speech recognition softwares struggle to perform well across diverse real-world scenarios because they're trained on such specific data. The difference with Whisper is that Whisper is only trained on 680,000 hours of unlabeled multilingual audio data, so very general data, which significantly enhances the model's versatility and reduces its reliance on this much larger, costly labeled data set.
So moving on to data representation and model architecture. So Whisper processes raw internet audio paired with weakly supervised transcripts, as Sam mentioned, utilizing a minimalist approach to data preprocessing. The core of Whisper is this encoder-decoder transformer architecture, which we're familiar with, capable of handling multiple languages and tasks simultaneously. This allows the model to be really scalable and is a very effective learning framework.
Yeah, so just diving a little bit deeper into the training process for Whisper. Whisper converts audio to 80-channel log magnitude MEL spectrograms, which are basically a version of the spectrograms we're familiar with from class, which are then processed by the encoder that Ethan mentioned. Then the decoder predicts the raw text directly. So the model employs kind of this data parallelism approach, and as well as the ADAPW optimizer for efficient training, which allows ultimately Whisper to learn robustly from this vast data set without having this problem of overfitting.
So just to visualize some of that, this is a diagram of the model architecture. So in the bottom left, you can see that log MEL spectrogram, the dense sound representation, frequencies, and then it's fed into this convolutional neural network and gets a positional encoding before working through the encoder-decoder blocks. Something really interesting is the multitask training tokens in the bottom right. So those allow Whisper to perform multiple tasks. So where a lot of the time, it's doing transcription, it could sometimes be doing other tasks. And so those tasks are labeled and have special tokens assigned to them, and that is how the model knows what task to perform.
Yeah, so now let's talk about the results. So unsurprisingly, as we've alluded to, the results of Whisper are very impressive. Whisper matches or even outperforms the fully supervised models that we've talked about in standard benchmarks, as well as the fact that its zero-shot transfer capability allows it to perform well on languages and tasks it wasn't even explicitly trained for. Furthermore, it's just remarkably robust in general.
Yeah, and so in conclusion, Whisper demonstrates high quality, robust speech recognition in all kinds of situations. Represents a significant advancement in making speech recognition more adaptable and accessible, being open source. It diminishes the need for expensive supervised data and opens up a bunch of new possibilities for research and application in real world scenarios. OpenAI encourages the community to engage with all of their release models and to further explore their development.
Thank you, guys.
Yeah, thank you.